Without using calculus, sketch the following polynomial function showing the behavior near any x intercepts. P of x equals x to the power of 4 multiplied by 1 minus x all cubed multiplied by x squared plus x plus 2. First, find the leading term. X to the power of 4 multiplied by negative x all cubed multiplied by x squared, and this equals negative x to the power of 9. The degree is 9, so it's an odd degree with a negative leading coefficient. The graph will stretch from quadrant 2 to quadrant 4. Next, we find the constant term. Now, the constant term of x to the power of 4 is 0, multiplied by 1, multiplied by 2, and this equals 0. Therefore, the y-intercept is 0, and the graph will pass through the origin. Next, we find the zeros and their multiplicities. X to the power of 4 equals 0. Solving that, we get x equals 0 with multiplicity 4. 1 minus x all cubed equals 0. Solving that, x equals 1 with multiplicity 3. And x squared plus x plus 2 equals 0, and this cannot be reduced to a product of linear factors since the discriminant, b squared minus 4ac, is less than 0, so there's no real 0. And finally, we sketch the graph, taking note of the multiplicities at the zeros and the long-term trend of the graph, so stretching from quadrant 2 to quadrant 4. So you can see that the graph here touches the origin, it bounces off the origin because it's an even multiplicity at that 0. And at the 0, x equals 1, or that x-intercept x equals 1, the multiplicity is 3. So it'll pass through, it'll actually cut through the x-axis, but it'll also be tangent to the x-axis there.